Hello everyone, I'm Vela and I'm about to present to you today my work on converged high capacity data and safety monitoring networks for the South African fourth industrial revolution mining industry. This work was also co-authored by my two supervisors, Tim and Shakri. Then quick overview of my work would be I'm going to introduce my work, talk about my experimental procedure, and thus my results and research outcomes. To introduce my work today, I'd like to highlight that after nearly 40,000 years in the mining industry, rockfall and explosions still are a point of concern, and not to mention the delay in data transmission because of the data technology that is used and also the complicated, unexpected geological mining conditions for mining environments. And without actually an efficient monitoring system, unexpected rockfall that is either caused by seismic activity with rock formation could actually result in injuries and fatalities. So, with the operation driven by big data machinery that can be remotely handled from a distance, the mining sector has tremendous potential to benefit from the 4IR. The objective of this work actually was to create something that looks like the image on the left, which is digital transformation, where we combine data, connectivity, and decision making and to make it into this whole system that makes life so much easier for people in the mines. So for this work, we combined data transmission that was high speed and efficient, as well as seismic tracking in one system. So for the data transmission, we actually created a transmission network which used multiple components which are more low cost, and we actually verified this network within a range of a small mine cavity. And also for seismic tracking, we actually created a seismic tracking system that actually used the same system and components and which was also verified through using fast Fourier transform analysis. The experimental looked at something a little like this. So basically, we connected our laser source, which was the one that we actually embedded with data, high-speed data of 10 gigabits per second over a multimode fiber that was 100 meters long. And then we actually looked at the results through the spectrum analyzer. And then for the sensing part of the work of this work, we actually connected the multimode fiber to a speaker now to at specific frequencies that we can detect at the end, such that we can be able to detect whether or not the seismic tracking system is working. So for the first part of the results, this work was we characterized our VXL, and the VXL output power and peak wavelength increased as the bias current was increased as well. The multimode fiber was characterized and calibrated for the wavelength shift for milliamps per bias current. And actually, the image on the left shows you how the outcome of an eye diagram that we got from the transmission signal. And it's actually clear to see from the above that the transmitted signal had a high extinction ratio and resulting in a clear distinction between the upper and lower level, meaning that by upper, I mean here, meaning that we could actually have a nice decision threshold and the data that we got was actually useful. Then for the seismic tracking part of the experiment, the detected vibrations were observed as a sinusoidal variation in the intensity of the polarization component S3, changing with time as shown in part A. And then on the right, the frequency component in the detected signal in signal A were then now observed in the spectral domain with a fundamental peak frequency of 70 and harmonics at integer multiples. Then on the far right, we can see the table of all the frequencies that we put. And if you look at the set frequencies and the acquired frequency, you can see that the percentage difference is relatively low. And we got an average of about 0.2% when we averaged all the percentage. And therefore, for this research outcome, we could depict that photonic transmission at 10 gigabits over 100-meter long multiple fiber could indeed be established and connected for underground minings, and the system could also simultaneously track seismic vibration. Therefore, we also noticed that we also can note actually that multiple fiber are an advantage over the normally used copper because they are non-spark and resistant to electromagnetic waves, which make them actually very ideal to be used in flammable gas combustible material and combustible materials. So then by providing a converged data and vibration sensing over the same optical infrastructure, the suggested technology indeed has the potential to increase productivity, cost, and increase the safety in mining applications. Thank you for your time.